Alright, so what I'm going to show you in this video is how to take the data you got from doing 100 trials for Fitts Law and turning it into the plot that you need to get the numbers that Fitts Law actually depends on. So my assumption is that you guys have read the links that talk about the movement time and the index of difficulty. So very briefly, the movement time is how long it takes to move from the starting point to the target when you're doing a study with a tracking device like Fitts Law is all about. That's what we measured, and it's already in column F of this spreadsheet. The index of difficulty is a little more complicated, and you guys have seen that it comes from a formula that has a logarithm in it, and it depends on the distance between the starting point and the ending point, and then also how big the target is. So those two things for the data I'm looking at, which is for a 1D simulation, and so we can tell that because all the y distances in that whole column C are 0. The index of difficulty depends on column B, which is the distance, the separation between the starting and stopping point, and column D, which is the target size. What we need to think about is what's the dependent variable and what's the independent variable in an experiment like this. We're measuring the time, the movement time. We don't have control over that. That means it's the dependent variable. The index of difficulty is what we do control. We have the distance and the width that we get to set up when I wrote the program to do this. That's the independent variable. When we think about plotting a dependent versus an independent variable, we want to have the independent variable be the x-axis. We want to have the dependent variable be the y-axis. So we're thinking like y is a function of x if this were math class. So in Excel, when we're plotting, what that means is we want to make a column for the x-axis. We want to make a column for the y-axis. The x-axis, if we make it come first, it's a lot easier. We can do a little more work if they don't come first, but this is the easiest way. If you're an Excel guru, you can ignore all this and do what you already might know how to do to make a scatter plot. So the x-axis is really the independent variable. The y-axis is going to be the dependent variable. For Fitts Law, that's the index of difficulty and the movement time. So what I want to do is for row 2, I want to calculate the index of difficulty and the movement time, and then I'm going to copy and paste it into the other 99 rows, and then we'll very quickly make the plot that we need. So the index of difficulty is a little difficult. It depends on the log base 2 of the distance divided by the target size, and then you add 1 to it. So the nice thing is in Excel we have a log function. So a plus sign tells Excel we're going to start typing a formula. Equal sign works too, but I'm old school, I use plus. The log function is log, and then the tooltip tells us that, okay, first argument we give it is the thing we're taking the logarithm of. Then the next part we give it after the comma is the base 2 that we want in this case. So it's distance, which is in the B column. We're on row 2, so B2. Divided by the target size, which in 1D is just the width, so that's D2. Then I'm going to add 1 to it. I want to take the log base 2. So that's it. We got the movement time. Excuse me, we have the index of difficulty. The movement time's just already there for us in column F. We're on row 2, so we want F2. So remember, the movement time is in milliseconds. The index of difficulty is, if we think about it, it's a logarithm. It's the ratio of two numbers, then you take a function of it. A ratio of two numbers doesn't have any units with it, so it's just a plain old number. The movement time is going to be in milliseconds. We have to think about this when we make the plot. So now I copied and pasted for the next 99 values. The nice thing is at this point I have my x-axis in the H column, my y-axis in the I column, and they're already highlighted. So what I want to do is I want to insert, and here you can see scatter, and I want to make a scatter plot without any lines on it, so the one that's just dots. So here I'm using on the only computer that my microphone's working with to make this video, I'm using Office 2010. In Office 2013 you still go to the Insert tab, you select a chart. In the lower right hand corner you'll see a scatter plot symbol. It'll look the same, no dots connecting the points. That's what you select. So it's a little different in Office 2012, but you guys will figure it out. So what I have here if we look at the chart I got, you see a clump of points. They kind of look like they fall along the line that I'm moving my mouse on, but not very well. That's the way experimental data is. It's all about statistical uncertainty. You may have a few points that are really far outside. Those may be outliers, or they just may be points that by whatever chance actually happened. If you know it's an outlier, like you were doing the experiment and your dog ran in and bit you on the leg and you didn't get to finish one trial for 5 minutes, that's definitely an outlier. What you would do is you would go back in and you would remove it from the columns over here. I don't really seem to have any outliers, so I'm happy with this data I have. What I need to do is I need to right click on the data points, and then I want to add a trend line. So the trend line we're going to get, we want to do a linear fit, and then the other thing we want to be able to do is we want to be able to see the equation on the chart. So what the linear fit means is we're going to look for a straight line through all the data, and then being able to see the equation means we're actually going to get the values, which is the slope and the y-intercept for this. So in this example, we have y is equal to mx plus b. M is the slope, and then b is the y-intercept. So we have a slope of 166.79. We have a y-intercept of 148.31. So the movement time, which is the y variable, is in milliseconds. So that means 166 times the x variable is in milliseconds. But x is the index of difficulty. It doesn't have any units with it. So that means 166.79 is a number in milliseconds. Likewise, the y-intercept, 148.31, is a number in milliseconds. So what this says in terms of Fitts' law is that it takes me 166.8 milliseconds to move one index of difficulty on the screen. So the further away the targets get, the more indexes or indices of difficulty you have, and the longer it will take you to move. It's also telling me that it takes me about 148 milliseconds to start moving. That's my activation time. This is using the mouse in 1D. If I look at my data with the trackpad, I'll see that I have different activation times, and it takes me longer, possibly, to cover an index of difficulty. So if you have small slope and small activation time, small y-intercept, we'll say that the pointing device is more efficient.